Alright, we are looking at solving another linear programming problem, and this time we're trying to minimize z equals 3x plus 5y, subject to 4y plus 5x is greater than or equal to 32, 3y plus 2x is greater than or equal to 16, y plus x is greater than or equal to 7, and our standard constraints of x is greater than or equal to 0 and y is greater than or equal to 0. And we're going to solve this by graphing. So I want to draw a coordinate system. We'll put our x-axis and our y-axis there. And we know that x is greater than 0 and y is greater than 0, so we're only interested in the first quadrant. In our first equation, if x is equal to 0, our equation just becomes 4y equals 32. And so dividing both sides by 4 gives us y should equal 8. So we're going to cross the y-axis up here at 8. If y is equal to 0, I'll get 5x is equal to 32. Dividing both sides by 5 will give us 6.4 for x. So 6.4 would be somewhere in this area. Come on, drive. There we are. And then I want to connect those two lines. 2 points with a nice line there. Alright, and if we check on that one, if we try the origin, if we try 0, 0, if you plug in 0 for y and 0 for x, you'll come up with the equation 0 is greater than 32. 0 is not greater than 32, so 0, 0 down here at the origin is not part of the solution. My solution region that I'm looking at is the opposite side. It's going to be out there. The part that does not include 0, 0, it's going to be that far spot up there. If on the second equation, if x is equal to 0, I'll get 3y equals 16. Dividing both sides by 3 gives us 5 1/3. So we'll be crossing the y-axis here at 5 1/3. My little drawing thing is being weird there. Just, I don't want to paste or anything. Go away. Yeah, it doesn't draw. Alright, so there's our thing. And if y is equal to 0, I'll get x is equal to 8. So I think that would be about there, right? 1, 2, 3, 4, 5, 6, 7. Yep, there's 8. So my second line, the 3y plus 2x equals 16, connects. Whoa. Alright, stay in that orientation. Connects those 2 points. And then I've got my last one of x plus y equals 7. There it is, x plus y equals 7. And so that's going to connect the points 0, 7 and 7, 0. 0, 7 and 7, 0. So I've got a line that kind of goes down between those 2 points. Like that. Alright, and again, for those two equations, 0, 0 is not a solution. If x is 0 and y is 0, I'll have 0 is greater than 16 or 0 is greater than 7. That means I do not want the area with 0, 0 in it. My solution region is going to be everything out here. So it looks like I definitely have a corner point right here at 0, 8. And I've got another corner point down here at 8, 0. And then I've got some weirdness going on there in the middle. I'm going to have to look at what's happening there, where those 3 lines are, I don't know if they're all 3 going through the same point or not. It looks like it's pretty close to that. So let's check that with that. Let's see, where does, I've got the 4y plus 5x equals 32, and I want to know where is that going to intersect with the point 3y plus 2x equals 16. And probably the easy way to solve that system of equations I'm going to do an elimination thing. Let's multiply the top equation here by 3 and the bottom equation by -4. Top equation by 3, bottom equation by -4. That would give us 12y plus 15x is equal to 96. And then -12y and 4 times 2 is going to be -8x. And 16 times -4 is going to be a negative 40, 24, carry the 2, 64, -64. So when I add those two equations together, I'll get 7x is equal to, y's cancel, 7x is equal to, ends in a 2, 32. Oh, well, I was kind of hoping that'd be a nicer number. But x would equal 32 over 7. And then y, let's see, if I eliminate the y's, if I multiply the top equation by 2, I'll have 8x plus 10y is equal to 64. And I multiply the bottom equation by 5, I'll have 15x plus 10y equals 16 times 5, which is 80. And let's make the top one all negative. So when I add them together, I'll get 7x. The y's will cancel, and 84 minus 14 is 64. Sorry, -64 plus 18 is 16. Is 16. So x is equal to 16/7. Or yeah. Wait a minute. I got my numbers backwards. That should be y. Y is equal to 16/7. There we go. Y is equal to 16/7. Okay, so that's where those two intersect. They intersect at the point 32/7, 16/7. And then if I look at 4x plus 5y equals 32 and x plus y equals 7, I've got those x and y's backwards. Let's just start all over here. 4y plus 5x equals 32 and y plus x equals 7. Let's see, I can solve, let's do a substitution on that one. I can solve x is equal to 7 minus y, so then 4 times 7 minus y plus 5x is equal to 32, and 28 minus 4y plus 5. Whoops, I need to replace that in place of the x, not the y. Let's try that again. 4y plus 5 times 7 minus y is equal to 32. And so 4y plus 35 minus 5y is equal to 32. And so I'll get 35 minus y is equal to 32. So minus y is equal to minus 3. So y equals 3. And then x is equal to 4. So I've got the point 3, 4, which I'm guessing is about this one here. That would be the point 3, 4. And if I look at the the last pair that I have there, which is the 3y plus 2x equals 16, and y plus x is equal to 7. And so I'll find where those two intersect. If I multiply the bottom equation by 2, I'll have 3x plus 2y equals 16 minus 2y. This problem is messing me up because they reverse the y's and x's from what I'm used to doing. But making you think, I guess, is what they're working on there. Multiply through the bottom one by -2 and add, I'll get a y is equal to 2. And if y is equal to 2 and x plus y equals 7, x has to equal 5. Yeah, 3 times 2 is 6. 2 times 5 is 10. 6 plus 10 equals 15. So that's the other point on the line. So the other point I have here is 5, 2. There's a 5, 2 intersection in there. And if I look at my x-coordinate, which was 32/7, which would be a little bit about 4, I don't think that's in the feasible region. It should be 4, 2, a little bit more than 4, a little bit more than 2. Yeah, I think that last intersection is not in the feasible region. So my corner points are 0, 8, 3, 4, and 5, 12. And I want to see which of those minimizes the z value there. So z was equal to 3x plus 5y. So if x is 0 and y is 5, I'll get 3 times 0 plus 5 times 8. That's going to give me a z value of 40. 3, 4. 3 times 4 is going to be 9. 5 times 4 is 20. 9 plus 20 is 29. 5, 2. That's 5, 2 there. Come on. 5, 2 is my point. If x is 5, I'm going to get 15. If y is 2, 5 times 2 is 10. So that gives us 25. And then 8, 0 down here is going to give us 3 times 8 plus 5 times 0. That's going to give us 24. And so that's our smallest value. Our minimum is going to happen at 8, 0, and our minimum value would be 24.